let's just do one more really quickly. So find the values of a, b, and c if this expression, x squared minus x, and these three lines, that mathematically that just means equivalent to a outside of x plus 3 all squared plus bx plus c minus 1. One thing you'll notice that compared to the previous one, right, this side is a lot less complicated compared to the one that we had before. And it almost looks like that, might not match up. But what you'll expect is when you do a similar process, right, these terms should simplify in that way. Okay, let's give it a go. So you always want to start with your right-hand side here, because remember, we're trying to find the corresponding coefficients, but we don't have that right now. I've got x squared and x over here, but right now I've got this mishmash of all these constant and coefficients. So what I want to do is, I want to take the right-hand side, and I'll just expand it. So ax plus 3 all squared plus bx plus c minus 1. If I expand that out, that's going to be equal to x plus 3 plus bx plus c minus 1. Let's keep expanding this guy, so just keep on foiling. So we've got a outside of x squared plus 6x plus 9 plus bx plus c minus 1. Whew, being lengthy. Alright, let's expand it out. So we've got ax squared plus, now be careful here because you've got all these coefficients. You want to multiply a by all of the terms inside here. We've got 6ax plus 9a plus bx plus c minus 1. And here's when you want to do your gathering skills, right? You want to see, okay, I've got this x squared term, that's fine. What have I got over here? I've got my x terms over here. Let's group those together. So I've got ax squared plus 6ax plus bx, and this 9a plus c, right, remember, 9a plus c minus 1, right, even though it's quite long, right, because there are no x terms in here, this is actually going to be your constant, okay? This is going to be your constant equivalent in that expression. So, what do we want to do next? Well, let's construct those equations, because we know that the corresponding coefficients in equivalent quadratic expressions are going to be equal, right? So if I know in this case here, like ax squared, that's my only x squared term, then I've got, in this case, sorry, not x, a here is going to be equal to 1, right? Because the coefficient of this guy, that's just going to be 1. So a in this case is going to be equal to 1. What do I do over here? Well, remember, I want to find the coefficient of the x term. So I want to actually group these guys together. I kind of want to factorize them, right? I can rewrite this as ax squared plus, in brackets, 6a plus bx plus 9a plus c minus 1. Right, all I've done is factorize the x out, so it looks more like this guy here. So I've got 6a plus b is equal to, what's my coefficient here? -1, right? -1. And last but not least, I've got my constant term, 9a plus c minus 1. That's equal to, I don't have a constant term. What should I do about that? Do we just kind of break it? Think about what is the value of the constant term here. What is its value? If the constant term is not in the quadratic expression, really, its value is just going to be 0, isn't it? You could rewrite this as plus 0, and it wouldn't change a thing, right? But because by notation we don't write that in, right, the constant value is actually just going to be 0. So now I can say that this equation, right, this part of the equation, that's actually equal to 0, okay? So I've got a equals to 1, that's my first piece. I'm going to use this guy, and I say, alright, sub a equals to 1 into this second one, so I've got 6 outside of 1 plus b equals to -1, and then I can rearrange that so I get 6 is equal to not 6 is equal to -7, b is equal to -7. Okay, that's my second piece. And then the last piece I want to do is, okay, I've got my a value ready, so sub a is equal to -1 again into this equation. I get 9 outside of 1 plus c minus 1 is equal to 0. C is going to then be equal to minus b. Looks about right. Cool. And there we've got our a, b, and c values. Easy.